Okay, so you have collected lots of concepts now. You're expert at bringing them together to make a bigger picture. And one of the best bigger picture you can build based on all the basic understanding you have built so far is El Nino. But let's first build another concept with everything you already know. Nothing new, but it's a new piece of information. So you make sure you understand it. What is it? It's called Walker circulation. How does it relate to everything you have learned? Everything we have learned is about atmospheric cells has been kind of simplified by zonally averaging and making a zonal mean and looking at the meridional section, because that makes it easier to understand the poleward circulation and the cells, the equator to pole temperature gradient, and so on. But the main idea was that the heating is maximum in the low latitudes, hence there is rising air, moist air rising, expanding, condensing, raining a lot in the tropics. A little bit of asymmetry because the IPCZ is asymmetric and so on, but nonetheless, we kept saying and showing many times that as the air rises, mass balance requires that there is convergence into the rising region, and we kept showing that the convergence happens from the north and the south, and we expanded it a little bit and showed that the Coriolis then makes the north-south winds into northeasterlies and southeasterlies, right? One critical thing we didn't mention is that uh, when you have these rising air, the rising air is not everywhere in the zonal direction. It is where the warm waters are. And we said the East Pacific is cold and the West Pacific is warm, right? The West Pacific warm pool, or the Indo-Pacific warm pool that we defined, has lots of warm water and lots of what is called convection in the atmosphere. Remember, we looked at the radiator in the room, and convection was when warm air was taking the heat and then moving up and out. That's convection in the atmosphere as well. When you have warm water, air gets warmer. Warmer air holds more moisture, so evaporation. And moisture makes the air even lighter. Remember, dry air is heavier than moist air. So moist air rises, low pressure in the upper atmosphere, expands, condenses, cools, and rains, right? So there is convergence into this region also from the horizontal direction, not only from the north and south direction. Okay? And we had said the air that rises hits the ceiling, the tropopause, and goes towards the poles. Well, we didn't tell the whole truth and nothing but the truth. Now we have to tell the other part of the truth, that the rising air indeed hits the ceiling and goes north-south, gives us the Hadley cells, but it also goes east-west. What is there to prevent it from going east-west? Right? So the rising air in the West Pacific is also going east-west. The air that's going west is sinking a little bit on the Indian Ocean around East Africa. The air there that's going east in the upper atmosphere after hitting the tropopause is sinking over eastern Pacific, where there is cold water. So the rising motion in the atmosphere is referred to as ascent or ascending motion. Not a big surprise. The sinking motion is called descent or subsidence. Okay, so wherever you have subsidence like the subtropical gyre or the East Pacific, you have high pressure, clear skies, no rain, dry weather. Of course, in the subtropics you have warm, nice weather, whereas in the East Pacific you have colder waters, cold air, and Galapagos can get pretty cold even in the summer, because the upwelling is maximum in the summer. Why? Because the trade winds are very strong and the divergence is very strong, and the water coming up is much colder. So now you can see how everything is getting related, right? So what is Walker cell and who is Walker? Sir Gilbert Walker was a officer in the East India government and placed in India, was a bit of a mathematician, a meteorologist, and he got concerned by the famines over India, and he had been exploring sea level pressures and so on everywhere already. And he was the first one to figure out these sorts of circulation, that there is convection and rising air and there is sinking on the other side. And this circulation in the Pacific is named after him, the Walker circulation cell, or the Walker cell. So you have the Hadley cell and the Walker cell. Hadley was way back from the 1700s, and Hadley cell invention, the discovery itself has a long story. Its physics is quite complicated and so on. But Walker cell, again, not so simple, but simpler. Rising air over the West Pacific, sinking air or subsidence over the East Pacific, and convergence into the West Pacific means, remember we talked about cold water in the East Pacific, high pressure, warm water in the West Pacific, low pressure, pressure gradient, temperature gradient, winds, low Coriolis in the tropics, so zonal winds. So there is a large-scale convergence happening from east to west as well to feed this convection in the west. So it is this circulation that we will look in detail is called the Walker cell. Okay, strong southeasterly trade, Pacific warm pool on the west is a critical part of it. The cold tongue in the east is a critical part of it, and the water that's being pushed to the west is piling up, and the thermocline is deeper in the west, 60 to 100 meters, and the upwelling brings the thermocline close to the coast of Galapagos, coast of Peru, and so on, so that the thermocline is close to the surface at about 30 meters. So we'll see these details in a minute, but just try to imagine all these things. We just added Walker cell, but it's not really new. You already knew exactly what goes into it, but after this explanation, you probably have a much better picture of why we are going to talk about Walker circulation more and more. So just remember that, look at it as many times as you have to and make sure you understood the Walker cell, which is the zonal cell corresponding to the meridional cells we've been talking about, like the Hadley cell. Very good.